Okay, so today, what are we doing? 225. Look at that, 225, 19. All right, so objective. Today what we're going to do is we're going to solve polynomials by finding zeros. Okay? So for today, okay, so we're going to solve polynomials by finding zeros. Sorry, it's so sloppy. For today, we're not going to have any answers that are unreal. We'll talk about those tomorrow. But for today, all of our answers are going to be real answers. So zeros in this case are two things. One, they are x values that make the equation 0, okay? So they are x values. So if I plugged in a certain x value, I don't know what it might be, but whatever I plug in, let's say it's 2, I don't know. Let's just pretend it's 2, I don't know. We'll figure it out, okay? If you plug it in, it would make the whole thing 0, okay? That's what it does. You find x values that make it 0, okay? They're also going to be for us, and they're also going to be x-intercepts for today. So if I just draw a funny little picture, just to give you a visual, okay, then in this example, thanks, my zeros would be here, here, and here. Visually it makes sense because at these points of intersection the y value is 0. Right? I mean, at these points of intersection, the y value is 0. So you find an x value that makes it equal to 0. That's your y value, make it equal to 0. Thumbs up. Does that make sense? Okay. So let's go ahead. Now, there's a couple of different ways to do this. One, yeah, sure, you could pull out your calculator and graph it, right? That will work. I'm being honest with you. You could just graph it, take a look, and sometimes you might have to use a little fancy stuff to figure it out, right? That'll work. However, if you know how to factor, it's faster, and you will need to factor on your test because I'm going to give you points for factoring, right? So, you ready? Here we go. Right off the bat, example 1. Let's factor. So the first thing I notice is I have a common multiple of 2, and I have a common x, okay? So if common factor out the 2x, what's left is going to be an x squared minus a 6x plus a 9 equals 0. And I can factor that again. Now stop me if I get going too fast. Okay, if you're like, whoa, Mr. Davies, what did you do? Please stop me. Okay? Just because I know how to factor doesn't mean you do. Got it, right? I mean, if you don't get it, please ask. Okay? Now, this is a regular old trinomial. Keep the 2x there. What are the multiples of 9 that add up to 6? Negative 6. How about negative 3, right? So we're going to have a 2x times a x minus 3. X minus 3 equals 0. Okay? And then, sure enough, there's 3 little mini equations, which is going to give me 3 answers. X cubed, 3 answers. Now, 2 of the answers are going to be the same, but we still are going to wind up with 3 answers. So, mini equations. Remember, mini equations? So, my mini equations are this. 2x equals 0. X minus 3 equals 0, and x minus 3 equals 0. Okay? Solve. Divide by 2. Divide by 2. And I get x equals 0, okay? Plus 3, x equals 3, and x plus 3, x plus 3, x is equal to 3. So this is what we're going to call a double root eventually, because it happens twice. We'll eventually call this a double root. We'll talk about why that happens, okay? But I did get 3 answers. Even though 2 of them are the same, I really got 3 answers. If I had to plug 3 into the original equation, I'd get an answer of 0. I really would. And you could try it if you want to, but you can trust me, okay? Trust me?
I trust you.
Thanks, Saul. Okay. All right. Example 2. How many answers? How many zeros?
There's got to be 4.
There's got to be 4. Everybody agree? It's got to be. Okay, so let's factor. So if it's an x to the 4th, let's see. First of all, I think I see they have a common multiple of 4. You guys okay with that? Common multiple of 4. So if I take out a 4, I'd have a x to the 4th minus a 10x plus 9. Okay, so x squared, sorry. Little side note, always common factor first, if you can. Okay, first, if you can. If you can common factor, always common factor first. It just makes the problem easier, okay? Now, oh, this should equal 0. Doggone it, you guys, put an equal 0. Looks like I found a mistake. I'm going to go back and fix that. Put an equal 0 there. So now, I'm going to factor this again. I'm going to go x squared. That makes sense because x squared times x squared, right? X squared times x squared makes x to the fourth. And what times what makes 9?
3 times 3.
Yes. And?
3.
9 times 1. Why is 9 times 1 better?
Because add up to 10.
There you go. How about a minus 9 and a minus 1? I like that even better, don't you, Saul? There you go. All right. So now, both of these will factor again, right? So then I'm going to factor that into 4 times x plus 3, x minus 3, x plus 1, x minus 1 equals 0. Okay. Now the mini equations, we're in Algebra 2. Do I really need to do them? Probably not. You know, but real quickly, don't get confused. See this 4? There's not an x. You will not get an answer. The 4 is irrelevant. Does that make sense? In fact, if you want to divide by 4, it disappears. Okay, I'll say it again. The 4 is irrelevant. If you want to get rid of it, I'm not going to, but if you want to just divide by 4, it's gone. See how that would work? But my answers come from the x's.
So it would be
Good, Daisy.
positive or negative 1 and positive or negative 3.
I like that. Let's go plus or minus 1 and x equals plus or minus 3. Do you guys mind if I use plus or minus?
Yeah.
Nice job, Daisy. Absolutely right. Okay, so we don't really need to do the mini equations if you can do them in your head. You guys agree? That's silly. That would be a pre-algebra kind of question. You guys agree? We're in Algebra 2 now. Okay, thumbs up. All right, example 3. How many answers? 5. Now we might get some double roots. We might get some double answers, but let's check it out. So first of all, it absolutely has to equal 0. Must equal 0. Must. So I'm going to take the 14x and bring it over. So I'm going to take this 14x cubed and bring it over. I'm going to put it right in order, okay? Bring it over. So how do I bring it over? I'm going to subtract it, right? So subtract the 14x cubed and put it right in the middle. Put it in order. x5, so I'm going to go 2x5. Then I'm going to go minus 14x cubed, then plus 24x equals 0. Okay? So first thing, get everything over to one side, make it equal 0 because we have to find the zeros. Second, what do you see? Good, nice job, Saul. Everybody agree a common multiple of 2x. If I common factor out the 2x, I'd be left with an x to the 4th minus a 7x squared plus 12, right? So far, so good. 2x, and I'm going to make this an x squared and an x squared, right? You guys okay with that? And then I'm going to have a, let's see, how about a negative 4 and a negative 3? Okay. All right. I'm going to get x plus 2, x minus 2. Right. Great question. I'm going to leave it. I'm going to do this one separate. Okay. What do I do about this x squared minus 3? I'm going to solve it. Okay. Because you guys can already see 0, negative 2, and 2, can't you? You guys see those? That seems pretty easy, right? 0, divide by 2, divide by 2. But this one, you're going to get x squared equals 3, right? Now, how many answers right here? How many answers? 2, right? So I'm going to take the square root of both sides, but I need 2 answers, right? So what I'm going to get is x equals plus or minus the square root of 3. So I did get 5 answers. I really did get 5 answers. I got a 0, negative 2 and a 2, and I got a plus or minus the square root of 3, okay? I really got 5 answers. Yeah, from here, right? From factoring that. So you have an x squared minus 4. I factor it into x plus 2, x minus 2.
Right.
right? You got it? And then the mini equations will give me a -2 and a positive.
Okay.
Now, I didn't do the mini equations, but we can, okay? I didn't set up the mini equations, but if I wanted to set up the mini equations, I can do them up here. 2x equals 0. I can go x plus 2 equals 0, and x minus 2 equals 0, and then just solve, right?
Yeah.
You go minus 2 plus 2 plus 2, right?
Sorry,
Yeah, okay, yeah. Okay, that was a little bit harder, wasn't it? You can do this, right? You guys can do this, right? Okay, and turn the page, right? Turn the page. All right, last but not least. All right, so example 4. I'm going to first take this 16x squared and put it right there. You okay with that? Let's put it in order. So let's go 0 equals 2x to the 4th minus 16x squared plus 32. Okay? 4 answers. Everybody agree? 4 answers because it's degree 4. So what do you see? Good. Take out a 2. And I'm going to have an x to the 4th minus an 8x squared plus 16. Okay? Let's go parentheses, parentheses, right? X squared, you guys agree with that? X squared.
Sure.
Because x squared times x squared makes x4, right? Right? What times what makes 16?
-4.
-4, because that will make a -8, right? So we'll go -4, okay? That'll factor again into an x plus 2, x minus 2, and this will factor the same way. X plus 2, x minus 2, right? All right, now, again, this 2 right here does not have an x. It's irrelevant. If you wanted to divide by 2, you could just get rid of it. Everybody see that? No answer, no x, right? So, but here, okay, you ready? We're going to just do it in our heads, ready? You can do this. If I solve for this, I'd get a -2, you agree?
Yeah.
So I'd have x equals -2. If I solve for this, what would I get?
2.
Positive 2, right? If I solve for this, what am I going to get?
-2.
Right? If I solve for this?
+2.
So there are really 4 answers, but 2 of them happen twice. Graphically, I want to show you what this looks like. Okay, graphically, this graph looks like this. So you see it. Okay? As an x-intercept, it goes through this point twice. I just try and think about that, okay? As an x-intercept, right here, it goes through -2 twice. You see how it works? And that's why I got this answer twice. As an x-intercept, it goes through this point twice. It goes through it and back through it again. Theoretically, it goes through it and through it again, right? And that's why you get the 2 answers. It's called a double root, okay? Something we're going to talk about later. But I like to throw a little extra in there, don't I? Okay? Okay, journal. Let's take a look at page 83, okay? Let's grab your journals and see what we got, okay?